Hello, good morning everyone. So let us start with digital switching system. So it is common for 15th as well as 17th skills of VTU 6M, Electronics and Communication Engineering. So we were at module number 3, so telecommunication traffic. In the previous classes we have discussed about introduction, units of traffic, definitions of telecommunication traffics like grade of service, busy hour, congestion, etc. So we discussed about traffic measurements, how traffic can be measured in different parameters and which are the things we need to consider and all we discussed. And we discussed about mathematical model, the derivations, and lost call system derivation also we discussed, I told already. So the mathematical model and lost call system are very important derivations in telecommunication traffic in digital switching system. So now we are left with the last topic in this particular chapter in the module, that is queuing system, so that we are going to discuss today. In the next class we will go with the next topic, that is switching system. So today let us go with this thing. So queuing system. So the second Erlang's distribution. What is an Erlang? I already told. The unit of traffic is indicated as Erlang, that is capital E. The second Erlang distribution they call queuing system. The Erlang determines the probability of encountering a delay when a traffic A is offered to a queuing system with n number of trunks. So, the Erlang is the name of the scientist who has determined the probability of encountering a delay when a traffic A, capital A, is offered to a queuing system with n trunks. The queuing system, the trunks are often called as servers. The Erlang solution depends on the following assumption. So how we discussed for last call formula, here also we have four assumptions. One is pure chance traffic, statistic equilibrium, and fully availability. Call which encounters congestion will enter to the queue and are stored there until the server become free. So the fourth assumption is quite different with respect to the previous one. So I'll repeat, call which encounters congestion will enter into the queue and are stored until the server become free. That means if there is any congestion in the medium, even the call occur, it will encounter congestion, and after encountering the congestion, it will enter into the queue and it will wait for the server become free. After the server become free, the call will be accepted. That means it will not be lost. Such system is sometimes known as M/M/N system, that is queuing system. So here in queuing system it is indicated as traffic offered in A Erlongs, that is queue. So this is the system. So these are N servers. So this is queuing system diagram. So the assumption 1, 2, 3 are common in lost call system also, as I told already. So let x be the total number of call in the system. Thus, when an x is less than n, then x calls are being served and there is no delay. When x is greater than n, then all the servers are busy and incoming call encounters delay. If x is less than or equal to n, if that is in absence of the congestion, the behavior of the system is similar to that of lost call system. That means if there is no congestion, means the system will behave as it is how it operated in lost call system. Okay, if there is a congestion, then we have to think about the second Erlang's distribution. We know this Poisson's distribution equation, that is P of x is equal to a to the power of x by x factorial and P naught for x varies from 0 to n. Okay, if you take, if x is greater than or equal to n, the probability of call arrival is very short period of time, that is delta t. That means for this condition, that is x is greater than n, the probability of call arrival is very short for a period of time, that is delta t. That is probability of A is equal to capital A, that is in traffic, amount of traffic, into delta T by H, where H means the service time. So this model we already discussed in the previous class, that is Markov chain model. That means the previous state of x is x minus 1. That means this indicates the transition of x minus 1 state to x. So P of x minus 1 comma x indicates the transition probability of x minus 1 state to x, and this indicates the transition probability of x state to x minus 1 state, that is P of x comma x minus 1. Okay, this is called state probability, that is P of x minus 1. This is P of x. The probability of transition form, that is x minus 1 to x call in the system during delta t. So delta t is a time duration during which the transition takes place x minus 1 to x. So P of x minus 1 to x. So P of x minus 1 into A into delta T by H, which is called as equation number 3. Since all servers are busy, as I told already, only the n calls are being served, that is given by P of E is equal to n into delta T by n. The probability of transition from x to x minus 1, that means from here to here, that is this, which is given by P of x to x minus 1, that is P of x into P of E. So P of E can be replaced by this equation. So the equation number 5 will become like this, because equation number 4 is replaced in equation number 5. For static equilibrium, we have, that is P of x minus 1 to x, P of x to x minus 1, we have, so P of x into n into delta T by H is equal to P of x minus 1 into A into delta T by H. So delta T by H will cancel. So we are left with P of x from the left hand side. So this n is coming as a denominator for A by n into P of x minus 1, and we know that P of x is equal to A to the power of x by x factorial into P naught, that is x squared is from 0 to n. That means we can replace n is equal to n plus 1, that is probability of P of n is equal to P of n plus 1 A by n P of n plus n minus 1. So 1 plus 1 and minus 1 will cancel. So we are left with P of n. Therefore, P of n is equal to A to the power of n by n factorial, that is P naught. If I take it as n plus 1, it will become A by n P of n. So we can also write it as A to the power of n plus 1 n into n factorial P naught. Okay, in a similar manner like this. In general, if you write for x is greater than or equal to n, P of x is equal to A to the power of x, n to the power of x minus n into n factorial into P naught. Okay, if you split this up, you'll get like this equation, that is n to the power of n by n factorial into A by n whole to the power of x into P naught. We can call it as equation number 7. If there is no limit to the possible length of the queue, then x can have any value between 0 and infinity. I'll repeat, if there is no limit to the possible length of the queue, then x can have any value between 0 and infinity. Therefore, the summation of x varies from 0 to infinity of P of x is equal to 1. That means sum of probability of P of x is 0 to infinity, it will be 1. Therefore, consider x less than n. P of x will become A to the power of x by x factorial into P naught. Then we have P naught is equal to P of x by A to the power of x by x factorial, where x is less than or equal to n. Consider x is greater than or equal to n by using an equation number 7. So now we have 1 by P naught is equal to n to the power of n divided by n factorial into A by n whole to the power of x into 1 by P of x, where x is greater than or equal to n. So 1 by P naught is equal to, we can have, if x is greater than n, this will be the equation. If x is less than n, this will be the equation. If x is greater than n, we have 1 by P of x. So modulus of A by n to the power of x, n to the power of n by n factorial. If x is less than n, we have 1 by P of x into A to the power of x by x factorial. At the equation number 8 and 9, we have 1 by P naught is equal to summation of x is equal to 0 to the power of n minus 1 A to the power of x by x factorial into 1 by P of x plus summation of x is equal to n to infinity n by n factorial a by n to the power of x into 1 by p of x. So that is also equal to summation of x varies from 0 to n minus 1 a to the power of x factorial into 1 divided by summation of x varies from 0 to n minus 1 into p of x. So since we know that this is equal to 1, right, plus this as it is I have taken and this also I have taken, okay, and here this p of x is replaced with this, okay, and this is also is equal to 1, we know that, right? So now this I written as it is, this 1 divided by 1 because this is replaced by 1, so plus, so plus the same thing I written here, so this thing I written here, this will become 1 by 1. So now the same thing equation I have taken, so here also I borrowed the same thing, 1 by 1 is 1, so I remove this, 1 by 1 is 1, so I remove this, so where k is equal to x minus n, so k plus n, if I take this one, is equal to x. Note that is p, that is summation of x is equal to n to infinity, p of x is 1, when summation of x is equal to 0 to n minus 1, p of x is equal to 1. So these two things we are considered here. Limits we need to take, x is equal to n, k is equal to 0, x is equal to infinity, k is equal to infinity, that we are going to use next. 1 by p naught is equal to summation of x to the power of x is equal to 0 to the power of n minus 1, that is summation limits a to the power of x by x factorial plus summation of k is equal to 0 to infinity n to the power of n factorial into a by n to the power of k plus n. Okay, this one, in the place of x we are replacing k plus n. So summation, so x is equal to 0 till n minus 1 a to the power of x by x factorial plus a to the power of n. So a by n, k plus n, I am just splitting it as a power n, so n by n into, so I'll just reverse, so this n will become upper, so a by n by n factorial, this one summation, this summation will come this side, a by, so since I taken n, we are left with k, so the k is as it is. So now 1 divided by p naught is equal to summation of n minus x varies from 0 to n minus 1. Let me repeat this again. From this point to here, so is equal to summation from as it is I have taken here, this also as it is I have taken here, plus, so here the whole thing a by n to the power of k plus n is there. No, I am just splitting it as a by n to the power of k into a by n to the power of n. So a by n to the power of n I have taken, so I just taken n inside, so a to the power of n by n to the power of n into, and this thing I have taken here, and the summation I am taken inside, so it will come here. So we are left with a by n to the power of k. I hope you understood. So come back to here, 1 plus p of 0 is equal to summation varies from x is equal to 0 to n minus 1 a to the power of x by x factorial plus a to the power of n by n factorial. We have summation of k varies from 0 to infinity into a to the power of n to the power of k. This is equation number 10, where k is equal to x minus n, since a by n is less than or equal to 1. Then summation of k varies from 0 to infinity a by n to the power of k is equal to 1 minus a by n to the power of minus 1, which is also equal to n by n minus a, since a by n is less than or equal to 1. So 1 by p of 0 is equal to summation of x varies from 0 to n minus 1 a to the power of x by x factorial plus a to the power of n by n factorial into n by n minus a, or p of 1 by p naught is equal to summation of x is equal to 0 to n minus 1 a to the power of x factorial plus a to the power of n by n factorial into, so I taken it as 1 minus a to the power of n to the power of minus 1, that is 1 by p naught is equal to summation, that means if you simplify this we can get through this equation, that is n into a to the power of n by n minus a into n factorial plus summation of x varies from 0 to n minus 1 a to the power of x by x factorial whole to the power of minus 1. So this above equation is known as second Erlang distribution. And kindly remember one more important thing is in your prescribed textbook which is there no, that is J flood, in that this much deeply fully explained derivation is not there. Kindly try to practice and remember the things such that you can write clearly in the exams. Okay, so I hope you understood. Kindly practice it slowly. We'll get into the thing. Fine. If anything is there, let's discuss. So now, so in this actually module number 3, we have covered half the portion of the module number 3. Only we are left with half the portion of module number 3. That is, so now if you consider the syllabus, so we have already completed this much. So we are left with only this much in this whole subject. If you complete this much, it is done, right? Switching system. So we'll discuss from next class. But for still, let us discuss some of the questions from previous year question paper or from model question paper which are taken and which are very important from this particular topic. So in previously they asked this many explanations or definitions like what is traffic, explain congestion, explain lost call system, explain grade of service or busy hour, fully availability, static equilibrium, pure chance traffic. Minimum 2 marks they will ask this. So it is very important. Kindly remember these definitions. Derive an expression for iterative formula for or iterative form of Erlang's lost call formula. So kindly remember I put a star mark also. These are very important questions for exam point of view. So derive an expression for iterative form of Erlang's lost call formula. So derive an expression for second Erlang's distribution. So derive an expression for second Erlang's distribution which we discussed just now, that is also very important. So next, this is a problem. During a busy hour, on average, a customer with a single telephone line makes 3 calls and receives 3 calls. Average call duration is 2 minutes. What is the probability that caller finds the line engaged? And this is a small problem. They may ask it for 3 marks, maximum 4 marks. And it is of some 2-3 steps. And we already solved. It is the answer is 0.2 airlocks, right? So that many things the caller get engaged is 0.2. Fine, not Erlang's 0.2. So probability will be 0.2. Its unit is not Erlang's. A group of 5 trunks is offered 2 Erlangs. Find the grade of service. Probability of only one trunk is busy. Probability that one trunk is free. Probability that at least one trunk is free. This problem is also important. I put a star mark and we have solved this problem also. Kindly practice. On an average, one call arrives every 5 seconds during a period of 10 seconds. What is the probability that no call arrives, one call arrives, two call arrives, more than two call arrives, where mu is equal to 2? This problem also we are done in the last class. It is very important. In these problems, out of these problems, definitely one problem they will ask. Here is they will ask. Okay. So one question definitely they will come. So it is for 16 marks. During the busy hour, on average, 30 airlines is offered to a group of trunks. On average, total period during which all trunks are busy is 12 seconds and 2 calls are lost. Find the number of call arrays and a group and average calls duration. So this is also a problem. The similar problem we already discussed. Try to solve this problem. Fine. We'll discuss if anything is there. Fine. So this completes this module. So the next module, sorry, same module, next chap portion I'll start next class. That is, as I told, that is switching system. So before that, let us go with model question paper from Vishwesvaraya Technical University. That is our university. What they are given, they are given set of 2 question paper, out of which this is the second set. Since we already discussed module 1, as I told many a times, different network structures used in communication is very important question. And see, for 8 marks they ask. Explain with a need diagram for 4-wire circuit. So see 8 marks. So important. With a block schematic, explain the national telecommunication network. Okay, that is also 8 marks. One diagram is there, you need to explain the national, international telecommunication networks. And this one, a small, simple problem, some 2 steps problems. So they are asking you to convert the power levels into dBm and dBW. It is very important problem. Definitely they will ask, kindly practice it. You will definitely will get 4 marks from this. With a suitable diagram, explain the principles of frequency division multiplexing. So they asked it for 4 marks. In this, the first module, we have frequency division multiplexing, time division multiplexing, SDH, PDH and all. So definitely they'll ask one question from this out of some 4 points. Okay. Explain message switching. So I repeatedly many a times I told in module number 2, message switching, circuit switching, either they'll ask you to explain or they may ask you to tell the difference. So see here they are asking for 8 marks explanation. Here to mention the functions of switching system they are asking 4 marks. Okay, and definitions CCR, BCCA, busy hour, very important, kindly practice. Or explain the significance of distribution frame with the help of a diagram. So there is a diagram, you need to practice it and write it neatly and explain it cleanly. Okay, there are some specific points in that, you need to highlight that. Okay, with a need diagram, explain the basic call process of incoming and outgoing through digital switching system. So about the software, that is second textbook. So how the call process of incoming and outgoing trunk will take place in digital switching system. Write the block diagram clearly, practice it very well. So it is important. Derive an equation for finite queuing capacity. So you need to practice the equation, the derivation. During a busy hour, the trunk is offered 100 calls having an average duration of 3 minutes. One call fails to find the disengaged trunk. Find the traffic offered, the group of traffic carried to the group, right? So actually in module number 3, so this is the problem. So similar problem we have discussed, so kindly try to solve this problem. If anything is there, let's discuss. Okay, obtain the relationship between first Erlang's and a second Erlang's distribution. So we need to obtain the derivation between the first Erlang's and the second Erlang's. So that you have to derive the equation. So this one still we are not done. So directly I'll go to the model number 4. With a need sketch, explain the space switch and time switch. So you need to explain with the diagrams. Space switching is what? What is time switching? So synchronization network you have to write as a note. You have note means you can write anything on synchronization network. It may be definition, explanation, equation, application, whatever it may be. Because they asked you to write a note, like a short note, for 4 marks. See the marks and write the answers, right? Explain with a diagram classification of the digital switching system software. So classification you have to write, there are 5 classification. Explain in brief the basic software architecture used in digital switching system. We have a diagram. So in the last classes we have discussed the level 1, level 2, level 3 and down. So everything you have to explain particularly. Okay. With a need diagram, explain the operation of n cross m space switch. Okay, again the diagram you have to take and you have to explain. Explain briefly the need diagram of organizer interfacing of typical digital switching system central office. That means the central office diagram you have to write and you have to explain each block particularly. Generic digital switching system hardware architecture. How we discuss software architecture, we have hardware architecture also. That also you need to write the diagram. You need to explain every block particularly. Explain the system outage and its impact on digital switching system reliability. So this is the last module, that is maintenance and reliability. You need to explain how the system outage will happen, what it will impact on digital switching system reliability, that and all you have to explain. Write a note on recovery strategy. Why the recovery strategy is used on which place and what are the strategy they are going to use and implement on digital switching system to recover the things when any problem or error occur or any shutdown occur. That is nothing but recovery strategy that you have to write a note for 4 marks. Draw a typical problem reporting a system and explain the function of each block. Okay. So this thing. So total 10. So out of 10, each will be having internal choices. So each module having 2 questions. Each question will be of 16 marks. This is a model question paper. Solution also I sent. So kindly check. Fine. So I hope today the things are you have understood. So I'll stop at this point. I hope you understood the things. We'll catch up in the next class. Thank you.